Okay, guys. Kicking off the stream. And we are live. Hi everyone, I would like to contribute to project. Since I've never done this, can anybody give me more information about the protocol? I saw this link. Is there anything else I need to read before starting? Nice. I think that's a great first step to get a high-level overview of the project. Also check out the pinned posts, language, champion, talk, etc. and read the README and roadmap. Okay, let's get started, guys. Your voice is breaking, crackling sound. Okay, let me see what's going on. Can you maybe check the sound? Let me just see what's going on. I should be using the Rode NTG, a good mic. Let me see if it still persists. Let me know. It sounds better now. Okay, awesome. Maybe it was on your side as well. No worries. Thank you for letting me know. Okay. So guys, we were profiling the parallel and sequential implementation of the min hash computation. And here are the results. So with 7 workers, we get this type of speed up. So we have 280 seconds for parallel and almost 1,000 seconds with sequential. So let's now try a couple of different number of workers and see what's the optimal value for this particular job. So let's see how much more of a speed up can we get. So I'm going to just quickly TS and TE. I'm going to quickly store these, copy them. So timing, so when we have 1 worker, i.e. sequential, we get this. We have 7, we get this time. Okay, let's quickly, oops. Let me quickly do the following. Now that we know that this is obviously a better implementation, I'm going to leave this one just because we know it works for sure. If there are any issues with the parallel implementation, we have the sequential one. But having said that, now I want to do some profiling. Let's do for number of workers or number of workers in range, let's say 1 through 16 or like 2 through 16. Do this. Remove this. Times. That should be a dictionary. And then we could do something like this. or simply something like this. And then at the end, print the times. We can put a breakpoint here, save this, stop the run. And additionally, let's just remove these. Okay. And now we can just do in the loop, build. Actually, let's use this one. So let's just build the LSH from scratch, a new one, then start the timing, run. Run, pass in the data sets. That's not going to change. This is not going to change. This will change. So we have to set the number of workers properly. So now I think this is correct. So for going from 2 to 16, we build the LSH, which is empty initially, and then we profile how much building takes. This should be good. Let's maybe go in the opposite direction. Let's go in a reverse direction, from 16 to 2 with -1. Okay. Let's try it. Okay, let's see how this works. So 16 first, kick it off. So the last one was with 7 we had, it sounds sharper. Maybe I messed up something. Hopefully, okay. Maybe I amplified the sound too much. I'm gonna check it later. So 280, that's like almost 5 minutes. That's too slow still. I would love to speed it up even further. Okay, while we are doing that profiling, let's see what else, what other tasks we've got. I'm profiling this. We need to figure out how to add some type of TQDM, some progress bar. Okay, gonna do some experimentation with filtering, and then we can transition to the prepare data stage. So TQDM. Let's maybe wait a bit more for this to finish. Or let's just keep on working. So this is the implementation of the TQDM multi-process. This is Eleutheri's implementation. I analyzed it before this morning. I was not streaming that. It's quite a detailed implementation with a lot of details with queues and stuff. So I'm not sure if it's worth the hustle. Let me see. Filter group. So we submit multiple jobs for each of the directions. And then ideally, I could track how fast each of them is progressing. How can we do that easily? I would love to extract just... Let me think for a second. The global TQDM. Whoops. 226. This is a bit faster. Let's see whether there is a better optimum. That's like below 4 minutes. That's cool for 2 million lines. Global TQDM. If I could pass in a global TQDM, the issue is we don't even see, with this current implementation, we don't even see the printing or anything. I'd love to know how we're progressing when we're running the filtering pipeline. That would be super, super good. I mean, we can introduce weights and biases and just track the progress. That might be reasonable. That's one option. If this is, I think that's going to be easier option than doing the TQDM stuff. Okay. Let me quickly skim through TQDM implementation once more. So here, let's see. They create a process pool, global progress, and then they pass in the global progress here. And then they update it. The issue is I don't know how many iterations I will have. Yeah, let's go with weights and biases. Okay, a bit slower with 15. If we see the trend is monotonous, we can just stop. So let's go with weights and biases. Sec. In the train, we have the weights and biases logic. Let's open up the train function. Train.py. Here it is. And let's see weights and biases. Somewhere in here. Maybe let's go to train, progress bar. Weights and biases progress bar. Just log stuff here. Init the project, and then keep on logging. Okay. Like this. And find the init logic. Project name. Okay. So project is gonna be called NLLB filtering, let's say. Run name is gonna be based on, I don't know, maybe by doing this, it's gonna automatically append some random suffix or whatnot. So I think this is good enough. And then inside of the filter directions, here we can have every now and then we can keep a track. Okay, definitely seems it's, let it run a bit more. Maybe there is some surprising behavior, but I doubt it's gonna be quadratic. It's gonna be likely just monotonic. So here the step is going to be what? How can we track progress with weights and biases? Let me see what makes more sense than log. Weights and biases, track progress. progress bar. Initialize. Sweeps. Launch. Where is the reference or something? So log is always used. PR curve, matplotlib, video, image, histogram, incremental logging. Tables. Let me see whether somebody's asking any questions. Okay, looking good. Okay, I mean, the simplest solution I can come up with is just do logging and then have a direction or something here. So like direction. Direction, and then the value should be well, we don't know in advance, right? We can maybe count it up quickly. Let's see. Datasets. Dataset. Okay, let's just count up the lines quickly. Exactly. Will this work? I think it will. So, counting lines. We can maybe cache this somehow later, but okay, for now, this is good enough. Enter. If the file exists, load. Well, if the file exists, then just continue. Otherwise, add to the number of lines. Okay, and then here, like this, and then I think we just need to log this. Does step need to be int, or can we just use a float? Let me see the reference again. Reference Python log. Step has to be integer. Okay. Well, if that's the case, then we will have to have this be here, and then the ratio up here. So this is going to be climbing up and up and up and up. Starts with 0, goes to 1. 0 to 1 on the y-axis, and on the x-axis we get the total progress for this direction. So this direction has this many lines, and this tells us how many we processed. Fair enough. And we do this how often? Let's say every 1,000 lines. Every 1,000 lines we log. Okay, and then in the second one, this is going to be direction before fuzzy, and then we want to have the same thing after fuzzy. Okay, this is going strictly linearly up. Let me think for a second. This is not after fuzzy. This is before. This is after fuzzy, or just fuzzy. So here, what do we want to use? It's total after. That's how many we can process. And let's just add a counter here. Counter plus equals 1. The step is going to be if counter divisible, then put the counter here and counter here. Actually, like like this. I think that's correct. So counter will be increasing, but at maximum we will have total after. And that's it. I think we now added so now I'm not sure whether there will be any issues with like concurrency issues, writing to weights and biases from multiple processes. But okay. So I didn't implement the TQDM, but I implemented something that kind of works. I've profiled this. 289. Let me see where we stand with the profiling. Okay, once this is over, we're gonna stop the run and kick it off again just to see whether weights and biases works. Okay, here it is. Almost done. Let me see if there is any comments, questions. Okay, super linearly increasing. Okay. So the more, the better. Surprise, surprise. Remove this. Build the parallel, insert, and that's it. Next up, we do this logic, filtering. This has to be done one by one. Let's try and run this. I will delete the fuzzy, or actually I'm gonna just rename it and rerun it. And now I just need to open up the weights and biases. Weights and biases platform. Aha, you must call the init before the log. Well, we did do that, right? I think. Here it is. Maybe every process has to do one or what? Let me see. Run. Okay, init. Okay, and then run. Aha. So we probably have to add init to filter direction. We might have to add the original name, otherwise we'll have different processes writing to a different project run. So how do we avoid doing that? We need to have something unique. We need to compute the run name from the properties here. Something that's unique across all of these. So for that we need to grab config, I guess. And grab config, grab, I don't know, maybe train primary. I'm gonna do it like this. VNDB run name. Run name, and this one is going to be something random, but shared among all of them. For directions, we need to even go a step above this, because filter group will be called multiple times, so we can't have different runs between primary and mine data. So we have to does this actually work? Or is this just hallucination? Let's just generate a random number. Do we have NumPy imported? Or math or anything? Okay. So now that we have this, config. Let's see whether this works. Put a breakpoint here and there. And run. It's not in filter config. Okay. Should work now. Initialize. Run. Projects. How did I name this project? NLLB filtering. Okay. Nice. So this is how it's gonna look like, guys. So English, Latin, Serbian, Cyrillic. Progress. And we'll just have a ton of these for every direction. And that's how we see that's how we see where we stand with filtering job progress. I think this is good. I'm not sure whether people use weights and biases for these types of use cases, but like I'm very happy with how this looks like. Let's test it for multiple directions just to see how it handles when different processes are logging to my project here. This is super cool. Let's just see whether after fuzzy works as well. Okay. Next up, let's just analyze different hyperparameters for the filtering job. Let me before that just double check that weights and biases works when we have multiple directions. So let's toggle on multiple directions. Croatian, Bosnian. And finally, Croatian. That's it. We have ourselves 3 directions. And only a single dataset open subtitles per direction. This is progressing. Let's just check that it works for the second stage of filtering as well, which is fuzzy deduplication. If anybody knows how to log progress as a progress bar or something, let me know. Let me see whether they even support such a thing. Custom chart. Scalar chart. Bar chart. It'd be cool if we could see the y-axis here. Huh. Precisely. That's what I was looking for. So this is the closest we can get. Plot bar chart using weights and biases. Bar plot. Okay, I guess we can just set it up in the project. It's always going to be log in the code. Apparently, that's how I understand it. There is a table. Aha. Custom bar chart. Plot bar. Okay, this just works for us. Almost done. Let's wait for it to hit 1. And then we should get another chart. Okay, now is between the two stages, we're building the LSH index. So that's why we're not seeing the new plot popping up. How hard will it be to train a LID model? I don't think it's going to be super hard to train a fast text model for our use case. Yeah. I think we should just push through and use whatever we currently have and leave that for the second iteration. Have a better language identification model in the second iteration. Aha. Okay, there's a bug here. Apparently. Does this work? Did we get a second plot? No, we did not. The given key does not exist. Key 0 does not exist. Oh. Yeah. Well, that's because I'm stupid. That's a bug. When building the LSH parallel, this is what we do. So we have to do the same thing here. When attempting to remove, I use I, and this should work. So we query, we find the results, we go through the results. If the index is different than I, but they are always going to be different because, again, let's convert both to integer or something like that. Like if we convert this to int and this should already be int. Yeah, I is already int. If they are different, in that case, remove this. Okay. Let's kick off the run again. We'll now have 3 processes. Each of them will be plotting its own plot. One, two, three. So far, so good. Nothing failing. Nice. Nice, 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 nice. Okay. So English, Latin, Bosnian, English, Latin, Croatian, English, Latin, Serbian. Nice. This is great, guys. I'm gonna let it run. Yeah, we actually still have a bug. Because I'm kind of assuming we only have the train primary. We also have train mind. So what happens when we... Let's see... Filter group. We first call the primary group. And then we block until the results are there. And then we do a second pass. And once that happens, this will not be enough to differentiate this here. So we have to have group name here as well. I'm also going to split on underscore and grab the last value. So that means we'll have primary and then direction and then before fuzzy. And I want to do the same thing for down below. Like this. Okay, so now each direction, each type of data, each stage, be it before fuzzy or fuzzy, will have their own plots. This is not good. Let's now start playing a bit with hyperparameters and kick up the job. Train an HBS tokenizer. Let me quickly just do something. Train primary. Comment out this one, just grab something that's shorter. Maybe Tatuiba. Okay. And then in mind, okay, in mind we can have whatever. Run again. We should now have explosive, very fast progress, because the table is much shorter. So we should see the, for the primary, we should see the pre-fuzzy stage and the post-fuzzy stage. Serbian, Bosnian, Croatian, why do we have two Croatians? Aha, this is fuzzy already. Nice. This is super cool. These are the primary ones. And here's the mind as well. Okay. Mind for stage 1. Awesome, guys. This is it. Works like a charm. Ideally, I would just separate this into separate, like these panels. Let me see how I've done that with... How have I done that with previous projects? Eval train. How do we do that? How do we separate this into separate panels? Open the stopes. And then progress bar. Come on. Prefix. Aha. We need the slash, I guess. Let's try and do that. So primary. fuzzy, and then direction. This will allow us to have 4 different panels. Before fuzzy and fuzzy. So again, group name, fuzzy slash, before fuzzy slash. Run once more. Actually, I need to stop the, I need to delete the output directory because of caching issues. Hit run. Let's see how this goes. Will I finally have the right here it is, primary before fuzzy. And primary fuzzy. And next up we'll have mind. Okay, so nice. We now have organized everything into separate panels. And this is now much nicer. Here is mind. Awesome. That's it. Fuzzy is different. We have exact deduplication and we have fuzzy deduplication. They're a bit different. Fuzzy is fuzzy. That means even if they are a bit different but super similar, then we're gonna filter out certain sentences. Okay, stop this. We are left with experimenting a bit with hyperparams. And I think we can in parallel start playing with training HPS LAD. Okay, guys, let's make a quick break, and then we're gonna test. We're gonna start some runs, some filtering jobs, and in parallel start learning about how to train our own LAD system. I'm gonna go stretch my legs a bit and grab some water, and then we can continue further. Okay, guys. Quick break, stretching, 4 minutes. Be right back. Let's go, guys. So, two things we want to do. One is tune the parameters and kick off the run. The second one is see how we can train HBS LID model in parallel. Okay. So with that, let's modify the... Okay, we want to use these three directions. That remains the same. And then we have to just uncomment all of the comments here. Okay. So Bosnian Cyrillic we can ignore. Serbian Cyrillic, we're using all of these data sets. Croatian, we're also using all of these data sets. And finally Bosnian, Latin script, we're using all of these data sets. Okay, looking good. Let me see what else. Go to the filter. We need to specify, of course, the settings, and let's also just commit the changes. So this is a new file, and then everything else is under filtering. We can commit that easily. Oops. Under the filtering, we have a couple more changes. Dedup, some new imports, new function, the worker, the build parallel, and the convert to line numbers. As for configs, I've added the weights and biases run name here. And here we've added some logging logic. We need to remove the TQDM here. And that's it. Remove the TQDM. Go to filter, TQDM. Let me just see quickly the design again. Okay. I think we can commit now all of this. Maybe just a quick check of the dedup here. Do some asserts. I'm thinking, can this mess us up? I'm just thinking whether there could be some edge case here. Could there be some edge case with the offsets here? That's my only fear. Let's quickly go through this logic again. Make sure it's sound. So number of lines in the data set. Cool. Then we find the offsets. This is the standard logic. Seek. And then safe read line. I think we'll have to use the safe read line. That's the thing. So, and then use the tell. Or let me see, because so we read the lines and then we are here. So offsets should be all aligned with some lines. Okay. And then convert offsets to line numbers. Go through the offsets. While it's smaller, increment. Can we put another assert here? Can we say the following? So if you're smaller than offset, okay, and then you read the line. So now you're not smaller. Can we assert that ftell is equal to offset here? Can we do this? Let's just test this hypothesis. This would be amazing. Then we know we are perfectly aligned. And then we add the counter and then we repeat. until we are smaller. And then at the end assert that the lengths are the same, that the first one is 0, that the last one is whatever the number of lines is. That would be amazing if this worked. And then there is this one, which I'm also afraid that might not work always. And then this is just standard stuff. We can remove the to do. We can easily remove the to do. Or let's call this one maybe document offset. Okay, let's run. Okay, unfortunately, I'll also have to again tweak with the directions and just allow a single file to be used, a single data set, just to speed things up. And delete this. Go to filter, pick up the job. Okay, here we are. Will this fail? Okay, it worked. Perfect. Perfect. Let's go. And it worked again. So that was my expectation, basically. Because of the safe read, because of the way how offsets were accumulated, I suspect that they are always aligned with the beginning of a line. So, yeah. This is great. This gives me a lot more confidence that this works properly. Convert offsets to line numbers. And then there is this one. Find offsets. This, I have a bit less confidence here, honestly. Let's see whether that's justified. Go that many lines and just do the safe reading. How could I be sure that this makes sense? Well, one way to be sure is to again convert offsets to line numbers and make sure these are the same. That will give me 100% confidence. So if this was the same as this, then we're golden. Let's go again. Okay, perfect. So we are paying a bit of a price here because we are counting the lines, finding the offset, which has to read the whole damn thing, and then convert the offsets to line numbers. Again, this has to read the whole thing. Okay. We can remove this too. That's it. Nice. Let me see whether somebody's asking questions. All good. Okay, let's now specify the hyperparameters. Kick up the run. And then in the background, start playing with the LID fast text training. Three makes sense. Digits to character ratio. If there is too many digits, we want to filter that out. I think this is all reasonable for the first run. Let me just see whether somebody from Eleutherii replied to my questions. Okay. Now just copy this all the way to laser and reuse it for train mind. That's it. Change the output directory and kick off the run. Okay, is there anything that can fail here? We have 3 directions. At one point we might have 30 processes because I've set number of workers to 10. Let me see, number of workers for fuzzy dedup filter. Let's expose that. Here, fuzzy dedup number of workers. Set it to 10. Okay. What else? Let me just think for a second. Is there any issue with memory at any point of time with fuzzy? Let me think about that. There is, because at one point we were running multiple parallel processes in the build LSH parallel. Each of them is holding the min hashes. That's going to hold a number of lines, min hashes. Right? So that means that at one point we will have all of our lines inside of all of the lines for this direction in the memory. That might be just too much. I think we might have an issue still. We might have an issue with the memory, with the current implementation. That's why Pile has been using pickles to store the min hashes and then read them, yield them one after one. We can do something similar. Because otherwise, we might just end up hitting memory bottlenecks. We also might not, because we only have 40 gigabytes roughly, or 30 for HBS. But later, once we start scoping up to like Slavic languages or whatnot, we will certainly cross the amount of memory that I have in my system. So what can we do there? What can we do? Okay. This is their implementation. So generating min hashes. They generate the min hashes, but they're doing everything batch after batch. So they have like batch sizes of 100,000, as you can see here. And then they keep on accumulating documents, and then they call process batch. And then in the process batch, they will process and have, at one point they'll have min hashes for that big batch, and then they take that and they pickle it, I think. And then they just pickle. And then in the dedup, in the load or create LSH, they again go and they yield min hashes, and then they insert. Okay, so the yield min hashes does what? Working with min hashes. The yield basically finds all of the files, sorts them, loads them open, and then one after one they yield one min hash at a time. So again, here the peak memory here will be batch, whatever the batch size is. That's how they reduce their peak memory. On the other hand, I have the whole data set in my memory. Let's fix that. That's a serious issue that might cause us crashes after a while, and then, like, I don't know, I kick off a run during the night and it crashes 4 AM because that's when we reach the peak or whatnot. So just to save myself time and misery, I'm gonna fix that first and then kick off the run. But let's think for a second how we can do that. Well, let's do a similar thing to what they're doing. Why try and be smart if there is already a battle-tested approach? Let's first commit what we have. Okay, we don't have to push it right now. Let's now fix this issue. So on one hand side, this is how we can do the inserts. We pass in the directory and then we just do like this. Exactly. So grab all the files, sort them, load from them, and then just yield. Okay, this looks good. So now for the part about dumping to the min hashes directory. They compute across the batch. And then they just dump. Tasks run. Create a temporary transaction lock. Dump. Okay. Okay, let me just understand what this old means. Checkpoint old, rename the current checkpoint to the old one, and then rename the temporary is the new one. Start the transaction, create a file, collect the data, dump wherever we stopped. Okay, let's just use this. We just need to see how to construct this directory. But we still might hit memory issues. Okay, once we start hitting memory issues, we can start dealing with that, but this is a good first step because we're running in parallel and all of these are slowly accumulating min hashes. So it means the memory is increasing. and then we dump. So I think we're not really solving the issue by doing this for now, but okay. Where should we be dumping this? Well, somewhere inside of the wherever our outputs are. Here. And then instead of min hashes. Okay, let's quickly go to filter. Where do we save stuff? Dataset output directory? Not really. Config output directory. Under output directory, min hashes. That's where we should save it. Okay, luckily we did pass the output directory here. We just didn't use it. So we can use that. And pass that to the filter here. And then modify this such that we have output directory specified. And also in configs. Okay. So we specify the output directory. And then here we need to pass this like this. Okay. Okay, that's it. So these ones are gonna dump the data there, and then this one is gonna read from the mean caches, yield the data, and that's it. Let me see whether somebody asked a question. Okay, batch after batch. We keep on doing this. Process the batch. Process the batch. Dumps the data. Okay. So now I think the only difference is they have like 100,000 documents. They process them in parallel. And that's their peak. For me, the peak is still going to be the size of the data set because I'm running across all directions, or at least up to 16. That's the batch size we have. And then I'm running all of these chunks in parallel, and all of them are equal size. So that means we will have a moment where we reach the peak in the memory, just because of the way we're doing it. Okay, let's handle the issues once they occur. For now, we have the right setup in place. Let's just quickly test it. Let's make sure that this works. Okay. Let's see how this works. Okay, this would have been a mistake as well. So we can just save this here. Each direction needs to have its unique path. Each direction has to have its unique path. Okay. That means we have to additionally add here direction. And then it will work. So where do we get the direction information? Let's just do something like this. Okay. This should do it. And then here, we just need to do this. And then we don't need this. And we don't need this. Okay, start again. Rerun. I have some error. Min cache is extend. What? Yeah, that's not supposed to be there. We don't need to do that. Which means we don't care about this. Okay, rerun. Filter. Run again. Kick it off. Okay, here it is. We sort them. Load. Yield. It doesn't have total after. How come? Maybe we just skip because of the cache the first stage and then this one fails, in which case, okay. Let's rerun. Okay guys, we are at the end of the stream. I'm just going to make sure that we kick off the filtering job, and then in the next stream we're going to go through the LID model training, figuring out how to do that. What do we need to have to prepare, which data we need to have to do that. Okay, it seems this is working. We are probably running the mine data right now. Yes. We're running the mine data. Okay. Stop this, guys, and clear. Uncomment this, save. Same here. And now we're good. Now we can just start the run. We have specified everything here. So we have the first stage, the second stage. We have all directions of interest, and we have all data sets. So that's it. Let's kick off the run. Hopefully nothing fails. And I'm just going to leave the weights and biases plots running and see how it goes. Okay. That's it. Awesome, guys. We've kicked off the filtering job. Finally, here are the results. This is going to be running in the background. After this is done, the good thing is, even if we fail, even if we have some issues with fuzzy, the first stage results are going to be stored and cached, and then we can just, if it fails, we can just hop from there and just go straight to the second stage with the fuzzy. So that's cool. Okay, I'm wrapping up this stream. As I said, in the next one, doing the LAD training. Cheers, guys. See you in the next one. Again, check out the Open NLLB channel to keep up to date with everything I'm doing related to the project as well as the streams. See you later, guys. Bye-bye.